The light bulbs that you may be most familiar with, called incandescent lights, work because of a phenomenon called thermal radiation. As electrical current flows through a tiny tungsten wire called a filament, which is inside the light bulb, it rapidly heats up and emits light over a continuum of colors from blue to red and even beyond the visible spectrum. Although this type of lighting has been used since the 1800s, incandescent lights are very inefficient and use a lot of energy to generate the heat necessary to produce light. A newer type of lighting technology, called light-emitting diodes, or LEDs, exhibit much higher efficiencies than incandescent lights and other types of lighting technology. LEDs are made from semiconducting materials, such as gallium nitride, and the materials used depend on which color the manufacturer is trying to achieve. Unlike incandescent lights, LEDs can emit light over a very small range of wavelengths, or colors, so it's possible to manufacture LEDs of any color. But how do they work? If we go ahead and remove the bulb, inside we'll see 8 individual yellow squares. Each one of these is a standalone LED. If we remove the yellow coating and zoom in, we can see the internal structure of the LED. As the name suggests, LEDs are diodes, which means electricity can only flow in one direction. This is achieved by selectively adding impurities to the LED crystal. On one side of the LED, these added impurities lead to an excess of negative charges, while on the other side of the LED, impurities lead to an excess of positive charges. Once a voltage is applied across the LED, both excess negative charges and excess positive charges will flow toward the center of the LED, where they recombine, emitting light in the process. This recombination of positive and negative charge inside what is called the active region happens millions of times per second and leads to bright, efficient light emission. Now, this yellow coating that you see on top of the LED plays a crucial role in the ability to obtain white light. An LED itself will only emit one color, and in this case, it's blue light. This yellow coating contains materials that are called phosphors, which absorb light of one color and re-emit light of a different color. In the coatings on white light LEDs, these phosphors absorb blue light and re-emit red and green light. The blue light, which is emitted by the LED, together along with the red and green light emitted by the phosphors, are observed by the human eye as white light. This method for producing white light is a much cheaper alternative than what is used in LED displays that may be in your cell phone or TV, where individual red, green, and blue LEDs are contained in each pixel.